Hello and welcome to today's lesson. We're going to be talking about topics under the standard 3.3 in 7th grade, and we're also going to be talking about topics under the study island lesson transformations. And so this lesson's mainly about different ways that you can move shapes left, right, rotations and flips, and then also how to make them bigger. And there's going to be some vocabulary associated with that, and you're going to want to make sure that you copy down that vocabulary so you can learn those words and any other notes so that you can have those to reference back to when you are working on these problems by yourself. And so if I go too fast for you to take notes, just go ahead and pause and rewind so you can get caught back up. That's the beauty of YouTube videos. And then you can also pause at the beginning of the question. You pick which answer you think is right, and then watch the video. And that way you can get a gauge to see if you're getting the questions right or if there's an area you need to work on. So I'm so glad that you're here, and let's go ahead and take some notes. There are 4 types of transformations you could see. The first one is a reflection, which is a flip, typically over the X or Y axis. So if you see the FL in reflection, that's a reminder that reflection means to flip it. This example here is an example of a reflection of the F over the Y axis. The second type is rotation, which is a turn. It pivots about a point. So here you can see this R is being turned or rotated on this point right here. And the T in rotation reminds us that, the double T reminds us that it's a turn. And then a translation is a slide. And most of the time it's either a slide vertically, so parallel to the y-axis, or a slide horizontally, so parallel to the x-axis. And the SL in the word translation reminds us that that means slide. And so here is 2 examples of a translation. The fourth one that you're going to see is a dilation, and that means that this image is either getting bigger or smaller. You can also see it called magnification, and that just means it's a dilation that's getting bigger. And so when it gets bigger, it just means that the side lengths of the images are proportional. So they're going to be the same shape, but different sizes. This problem asks us to describe the translation that is shown between these 2 figures. So we have the green triangle down here, and how does it move up here? If we look at our options, vertically negative 10 units, that means moving down 10 units. I look horizontally negative 10 units, that's talking about moving to the left 10 units. Then moving horizontally positive 10 units, that's talking about moving to the right 10 units. And then vertically positive 10 units is talking about moving up 10 units. So if I pick one triangle, one point on the triangle, and I look at it in both places, and I look at, okay, that point, does it move up, right, left, or down? That's going to tell me which direction this translation is moving. So I can draw that point over here also. So this point is at 4, negative 4, and so I can draw it right here to help me count. And then I start here and I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units. So since I went up 10 units to get to the new point, that means that I am going to be moving D vertically 10 units. This question here is talking about another translation, so it's going to be a slide because of the SL. That reminds us the definition of translation is slide. And this one here, once again, is it moving vertically or horizontally, and then positive 10 units or negative 10 units. So if I look here, my object starts here and ends over here. So it's sliding to the right. So a slide to the right is going to be a horizontal in a positive units. So that means the only one that's positive units with a horizontal is going to be B. And if I were to count how many units this corner moves, it would count out to 10. Here's another example of a translation, but this time the answers, instead of giving it in the vertical or horizontal, it actually says in the X direction or in the Y direction. So you can see here that this one has been slid both horizontal and vertical. So I'm going to look at this coordinate here. This coordinate here is -2, -4. So I'm going to draw it in over here also. And this corner of my object is the same as this corner here. And so I need to count how many units does it move over in the X direction, and then how many does it move in the Y direction. So in here, they label the X-axis X to help you know, this is the X-axis. It goes left to right. So when I count for the X, I'm going to be counting left to right. And the same with the Y, up and down. And so from this direction, it's going to go 1, 2, 3, 4, 5, 6, 7, 8 units in the X direction. And then when I count up, it's going to be 1, 2, 3, 4, 5, 6, 7 units in the Y direction. So that's going to make my final answer here B. This question here wants to know which graph shows only a translation, so only a slide. So if I look here, this object, they look the same, just moved over, just slid over. It hasn't been rotated or changed. It's the same direction, just slid over. So that's going to be my translation. If I look at 2, the triangle has been turned and slid, so it can't be 2 because it has the turn in it. And the same with 3, the triangle has been turned also. And then here, the triangle's been flipped over the y-axis, so it can't be 4. So that's going to make my final answer A, Roman numeral 1. So in this graph, it asks about a rotation, about the graph on the point 4, 1. So what I'm going to do is I'm going to put a little dot at the coordinate 4, 1. So you can ask for graph paper on your test so that you can copy this down if you want to, so that you can put that point there also. And at home, you could print graph paper off and put it in a page protector and use a dry erase marker so you can use that graph paper over and over again. And so here we're just looking for, if we take this object and just rotate it along that corner, what could be a new picture? So here, this one here, it's been rotated, but it's also been flipped because this part of the shape is on the wrong side, so it can't be W. Okay, and then X, it's just been flipped in that area because this part of the shape is on the wrong side. And then Y, it's rotated on 4, 1. However, it's also been flipped because this part of the shape is on the wrong side. And then Z, here it has been just rotated along because finally this part of the shape is on the right side. So my final answer here is going to be Z, which is choice C. This question here is similar. It's another rotation, but this time it's on the point 1, -2. And I went ahead and put a dot on the graph at 1, -2. So that means I'm just you can picture it, you're just holding down this edge of the shape and just using your other finger to rotate that around. And so if I look at choice W, and I look at it, this one I could just rotate the shape down, and that would give me the picture W. So that is going to be my rotation. Whereas these other shapes here, the shape also gets flipped as part of the rotation. So parts of the shape are in the wrong spots. So that's why my final answer is going to be W, which is choice C. In this question here, we're asked to identify which of these types of rotations do we see. So how does the object get from 1 to 2? Well, it looks like somebody just held down this corner of the shape and rotated it over. And so that's going to make it a rotation because it's pivoting on that point 5, 5. So B is my final answer. Now this question here asks us which graph shows us a reflection across the y-axis. So reflection, remember, has that FL in it, so that's to remind us that that means a flip. So that means that you're going to flip it over the y-axis, and they label the y-axis for us, so we know that that's the one that goes up and down, or vertical. So here, if I take this object and just flip it over to the y, it should be over here. And so it's not going to be I. It's in the wrong spot. Now 2, it's been flipped over to the right location, but the object has also been turned. So it can't be 2 because it's not, you should be able to fold it on the y-axis. And if you were to hold it up to a light, those two shapes should be directly on top of each other. And so if I were to fold this, they wouldn't line up. So it's not going to be 2. Then in choice 3, this one's just been slid. So it's not going to be choice 3 because it's not flipped. It's just slid. And then choice 4, finally, we see that if I were to fold this one on the y-axis, it would directly line up. So it's just been flipped over on the y-axis. So that's going to make my final answer choice 4, which is letter C. Now this question is dealing with a reflection, but this time the x-axis. And remember, they label the x-axis to help you remember that that is the horizontal or the left to right axis. And it wants to know which one is the reflection across the x-axis. And so that means if I were to fold it on the x-axis and hold it up to light, those shapes would be right on top of each other. They would match perfectly. So X here, if I take this object and flip it over, these objects will line up if I hold that up to a light. And so that's going to make I, or number 1 there, my correct answer. Whereas 2 was a slide, 3 was a slide, and 4 was along the y-axis. If it was along the x-axis, the object should be down here. So that's going to make D my final answer. So which graph above shows a magnification of the object of the graph below? Remember, a magnification is the same as a deletion. Just it's going to make, you're going to have the same shape, only it's going to be bigger. So what that means is this shape here is 3 across on the top, 3 across on the bottom, and it's 2 blocks high. So I'm going to be looking for an object that is proportional to that. So there's a number I can multiply by that to get the new dimensions. So here, it's still too high, 2 blocks high. So that means that it didn't get bigger in the height way. So it can't be I because it has to get bigger lengthwise and height-wise. So 2, it went from a height of 2 blocks to a height of 4 blocks. So 2 times 2 is 4. So that means that my width in the top is 3. 3 times 2 is 6. I'd have to have a width of the top and 6 here. And I do have 6 blocks there. And the width of the bottom was also 3, so 3 times 2 is still 6, and I have to have a width of a 6 in my bottom part, and I have a width there too, so that means this one is still the same shape, it just got bigger. It's proportional because it is, I can multiply all the dimensions of the first one by 2 and get this shape here, so it's going to be 2. Whereas 3, it was just flipped, and then 4, it grew height-wise, but it didn't grow lengthwise, so it can't be 4. So that's going to make my final answer choice C. So this question here asks which of the following shows a magnification. So I have these all. Magnification means I start with something small and it gets bigger. So right away, W is still the same size and X is still the same size. So it can't be W or X. So it's either going to be Y or Z. And when I look at those two, I have to look at the lengths of the sides to make sure they're proportional. And when I look at Y, it went from being a hexagon to an octagon, from having 6 sides to 8 sides. The object completely changed, so it can't be Y. So that leaves me with Z, and when I look at Z, this side of the triangle is 2. The new triangle is 4, so 2 times 2 is 4. That gives me, and I have to check to make sure the other sides work that way also. So the width of this bottom here is 2. 2 times 2 is 4. The width of the bottom is 4, so that checks. This hypotenuse goes 2 blocks, corner to corner, and this one goes 4. 2 times 2 is 4. So Z does check out, and so it's going to make my final answer D. Thank you for joining us today, and I hope you learned something new.